Hi, it's Carly McAvoy. I want to talk to you about inverse variation. And inverse variation is when one quantity going up or down causes another quantity to go down or up proportionally. They change in opposite directions. A good example is having living with roommates. Your landlord expects a certain amount of rent each month, but if you have more roommates, you have to pay less rent per person. If the rent for the house is $1,200, two roommates would pay $600 each. If you got a third roommate, you'd each pay $400. The more roommates you have, the less you personally have to pay. So something going up causes something else to go down. That's inverse variation. And the constant K in this example is the amount of rent charged per month by the landlord. That stays the same. The thing that is varying is the number of roommates, which we call X, that live in the house. That's the independent variable. It varies, and that causes a change to the dependent variable. And that, in this case, is the amount of rent that you personally pay, and that's what we call Y. So we have a dependent variable, Y, that changes when something else changes. So the thing that we would say is the independent variable is the number of people living in the house. Okay, inverse variation, Y equals K over X. That's the formula that we're going to use. To solve this problem, we first find out what K is by plugging in the X and Y that we're given. And then once we know what K is, we plug that in and the other variable that we're given and solve. So it's only 2 steps. It doesn't take very long. Here's an example. When the Kansas City Royals cleaning crew is at full staff, they have 225 employees. It takes them 8.5 hours to clean the stadium at the end of a game. Working at the same pace, how long would it take 130 employees to complete the same job? Okay, so first of all, see how this is inverse variation, because you have a job to do, and if you have more employees working, it should take them less time. If you have fewer employees, then it's going to take them more time to get that job done, right? So the constant is there's one huge amount of time that it takes, but depending on how many people are pitching in to work on that, that changes things, right? So what is K? Well, K is the set time required to complete the job of cleaning the stadium. And that's what we want to find first, is what is that K? In this case, X, or the independent variable, is the number of employees on the cleaning crew, because that goes up and down. And when that goes up and down, that changes Y, the number of hours it takes to complete the job, right? So it takes the crew to complete the job. So we have Y equals K over X. We know 8.5 hours for 225 employees. That's called the equation of variation. We put the X and the Y in. That's our equation of variation, and that allows us to get K. Multiply both sides of the equation by 225, and you get K equals 1,912 and a half. So now that you know K, you plug in the K that you know, and the other value you were given. We know that now instead of having 225 employees, we have 130. So we put the 130 in, and then we divide to find out that it takes this crew 14.71 hours. It should make sense that a smaller crew is going to take longer to complete the job. One thing going down caused something else to go up. Sometimes you might just see it written this way: if Y varies inversely as X, and Y is 48 when X is 8, find Y when X is 12. Inverse variation is always Y over KX. We want to find the equation of variation by plugging in the X and Y we were given. X is 8, Y was 48. Multiply both sides of the equation by 8 to get 384. That is solving for K. And then just go back to that same basic equation, plug in the K that you know and the X you were given, and divide to find the Y. Notice in this case, X went up, so our Y went down. That's inverse variation. All right, have a fantastic day, and I'll see you next time.